Hi there, and welcome to this lesson on Pure Mathematics 1. In this lesson, we'll be considering the intersection points of curves. Now, if you have two functions and you want to find the intersection points of the curves of those two functions, then what you have to do is solve the two functions simultaneously. If you're ever looking for intersection points of graphs, it could be two straight lines, it could be a straight line and a curve, it could be two curves. It really doesn't matter what they are. The question will always come down to solving two equations simultaneously, and that'll give you the crossing point. So, for example, in this example, we're asked to sketch the two curves. There's a cubic curve and a quadratic, and once you've sketched them, you're asked to find the coordinates of the points of intersection of the two curves. I'll let you have a go at this yourselves first. So pause the video and come back to me again when you're ready. Okay, let's have a look at this. So the first thing we're asked to do is sketch the two curves. We'll sketch the quadratic first of all, and we'll do that in the normal way. We'll find the crossing points on the axes. First of all, the crossing points on the y-axis, which is where x equals 0. Now, if x is 0, we've just got 3 in this bracket and minus 2 in that. We'll have 3 times minus 2, which is minus 6. That'll be the crossing point on the y-axis. To find the crossing point on the x-axis, we say what happens if y equals 0. Well, if y is 0, that means x plus 3 times x minus 2 is 0. For that to happen, one of these brackets must equal 0. So either x equals minus 3 or x equals 2. That gives us all of the crossing points on the axes. We can sketch those now. We've got a quadratic. It's a right way up quadratic. So there is only one thing that it can look like. It must look something like that. Then we do the same thing for the cubic. So for the cubic, we've got 3 brackets multiplied together. We use the same method. To find the crossing point on the y-axis, we say what happens if x equals 0. If x is 0, we'll have 3 times 2 times minus 1, which gives us minus 6 again. So the crossing point for the cubic is also minus 6 on the y-axis. To find the crossing points on the x-axis, we say what happens if y equals 0. Now, if y equals 0, that means these 3 brackets multiplied together must give us 0, which means one of the brackets must equal 0. So if the first bracket's 0, we'd have minus 3. If the second bracket's 0, we'd have minus 2. And if the third bracket's 0, we'd have plus 1. Those are all the crossing points. We can sketch those now. We've got a right way up cubic. If we multiplied all these brackets together, we get plus 1x squared. So it must start down here in the bottom left. It's going to go up, it'll come back down, and then go up again. It must look something like this. That's the sketches done. The second thing we were asked to do was find the coordinates of the points of intersection of the two curves. Well, that's these 2 points here. Now, the normal method is to solve the 2 equations that we have simultaneously, and we will do that in a moment. But it's worth noticing, first of all, that in this particular case, it is possible just to write down the answers straight away, because this first crossing point is on the x-axis. And so the coordinates there must be minus 3, 0. And this crossing point is on the y-axis. So the coordinates here must be 0, minus 6. So by inspection, we could just write down the answer straight away. Minus 3, 0, and 0, minus 6 are these 2 crossing points. But we'll do the formal method as well, just to show how that works out. So if it wasn't as simple as that, then what you would normally have to do is solve the equation simultaneously. Now, the first equation is y equals x plus 3 times x plus 2 times x minus 1. The second equation is y equals x plus 3 times x minus 2. So both of these things are equal to y. That means if we solve them simultaneously, we just have to say they must be equal to each other. Multiplying out all the brackets, and I won't give you the detail, I'll go straight to the answer on this, but if we multiply these 3 brackets together, we get x cubed plus 4x squared plus x minus 6. And if we multiply the 2 brackets together on the right-hand side, we get x squared plus x minus 6. Tidying the terms together and collecting them, that simplifies to x cubed plus 3x squared equals 0. Factorizing that gives us x squared times x plus 3 equals 0. So either x equals 0 or x plus 3 equals 0, which gives us two possible solutions for x, either 0 or minus 3. And then what we'd normally have to do is go back to the equation for y to work out what x is. If x is 0, then y is minus 6. And if x is minus 3, then y is equal to 0, which gives us the two crossing points that we had before, 0, minus 6, and minus 3, 0. Okay, example 2 is slightly different. Again, there are two curves. This time the first one's a cubic curve, and the second one is a reciprocal curve. We're asked to sketch those on the same diagram. And then the question says, state, giving a reason, the number of real solutions to the equation x times x plus 3 times x minus 4 is equal to 4 over x. Well, the equation we've been given is the same thing as saying, when is this first curve, this first function, equal to this second curve, this second function? So solving these two things together is asking the same thing as we were doing just now. It's saying, when does the first curve equal the second curve? Well, that's when the two curves cross each other. Now, we haven't been asked to find the crossing points, but we have been asked to find out how many there are. But that's all we're asked to do. I'll let you have a go yourself first, pause the video, and then come back to me when you're ready. Okay, let's have a look. We'll do the reciprocal curve first. It's y equals plus 4 over x. Now, if you have y equals plus anything divided by x, the curve has the same shape. All of them will look like that. So y equals 4 over x will have that general shape. The cubic curve, we do the same thing as before. We find the crossing points on the axes. First of all, the crossing points on the y-axis are where x equals 0. Now, if x is 0, we'll have 0 times by these two brackets. So the answer will be 0. So this curve crosses through the origin. It goes through 0, 0. To find the crossing points on the x-axis, we say what happens if y equals 0. But if y equals 0, that means these three brackets multiplied together give us 0. The first solution is x equals 0, which we've actually already got. We know it goes through the origin, 0, 0. The second solution will be minus 3, and the third solution will be plus 4. So those three crossing points on the axes are here at minus 3 at the origin and plus 4 on the x-axis. It's a right way up cubic curve. If we multiplied out the brackets, we'd have plus 1x cubed. So it's going to start down here. It'll head up. It must come back down through the origin and then go back up through 4. That's the only way you could draw it. So it'll look something like this. Now, the question asks us to find how many solutions there are to this equation. Well, the number of solutions to this equation is the number of crossing points of the two curves. And if you have a look, there's a crossing point here on the left-hand side, here on the right-hand side. There are two crossing points. Now, they're not asking you to do any more than that. They just want you to write down something along these lines. There are two real solutions because the two curves intersect at exactly 2 points. So because there are two intersection points, there will be two solutions to this equation. That's what they're looking for. Same idea in this third example. Again, you've got two curves to sketch, a cubic and a reciprocal curve. I'll let you have a go at doing this yourself first. Exactly the same as we did last time. Have a go and then come back to me when you're ready. Okay, let's have a look. So first of all, we'll sketch the reciprocal curve, y equals 2 divided by x squared. Now, y equals a positive number divided by x squared. All those curves have the same shape. It'll all be positive because of this x squared and because the 2 is positive. So it's all above the x-axis and looks something like that. Then we need to sketch the cubic curve, y equals x squared into x minus 4. Find the crossing point on the y-axis. We see what happens if x is 0. And like the previous example, if x is 0, we'll have 0 times this bracket. So y will equal 0 as well. So again, the origin is a crossing point. To find the crossing points on the x-axis, we see what happens if y is 0. If y is 0, then x squared times x minus 4 equals 0. That has two solutions. The one that we just found when x is 0 at the origin, and the other one will be when x equals plus 4. So, drawing those two intersection points, there's a point here at 0, there's a point here at 4. It's a cubic curve. We'll have plus 1x cubed if we multiply the brackets. So it is going to start bottom left. It is going to finish top right. We have a repeated root at x equals 0. Because we've got x squared here, we've got x times x minus 4. So this root here at 0, we get it twice. The significance of that is if you get a repeated root, the curve is going to touch the x-axis there. It's not going to cross it, it's just going to come up and touch it. That's the consequence of having the repeated root, x squared. So the curve will look like that, touching the axis of the origin. It'll go down to a minimum somewhere, and then go back up and cross through at 4 again. So that's what the sketch should look like. We're then asked to find how many solutions there are to this equation. Well, same as the last question. This first equation here, x squared times x minus 4, that's the red curve. 2 over x squared is the green curve. What they're saying is, when does the red curve equal the green curve? Well, that's when they cross each other. And this time, there is only one crossing point here, just beyond 4. They're not asking you to do any more than that, and they want you to write down something along the lines of, there is one real solution to this equation because the two curves intersect at exactly 1 point. That's all they're looking for. Okay, that gets us to the end of this lesson. If you have the textbook, then turn to page 65 and have a go at exercise 4C. Thank you very much for listening, and cheerio.